Welcome to Darshana's YouTube live channel. Right? From last few months, we all are helping you. So, final stage, we are there to support you with all the necessary work which you want us to do. Right, children? So, myself, Bindu and Pillai is dealing with inorganic chemistry. You know, this is the most easiest part where you can score the maximum marks for chemistry. So, don't stress, do your best and forget all the rest because might be the path might be difficult, but your destinations are so beautiful, children. So, that path to make it to the right one, we are here to support you. So, let's begin with our class, right? So, how to prepare for inorganic chemistry. This is the first thing you should know because even though you might be tense because inorganic, so many things are there. How you will exactly go for preparing that final 10 days, how we can go for. These are certain tips. Children, please stick to the tips. Definitely, the 15 questions which will be coming from the inorganic will be apt for you. So let's go for those tips. Please stick to your NCRT, which the rest of the portions might not be there. But definitely for inorganic, you stick to your NCRT only. Solve 10 years previous questions thoroughly, knowing all the concepts properly. What we have done there, that concept should be apt to you. So solve that 10 years question papers. I'm damn sure that you will get that 15 questions properly. Next, study 1 hour daily, morning and night time. That's a request from my side for your morning when you get up and night before sleep 1 hour. If you prepare, definitely I'm sure that inorganic will be right at your tips. You can prepare such a way from today night, right? Prepare two topics because we have few days. So morning and night time 1 hour, and those all cut short methods here we are there to help you. Now, how you can prepare, how you will begin with. Don't start with a difficult chapter. You should have a confidence. That's why the order or priority listed, this is helping you. You can go for periodic, S block, P block, then DNF block, bonding, coordination, compounds, metallurgy, hydrogen, environmental, and chemistry in everyday life. This is the priority order which I am telling you all because this is from easy to a little bit difficult part which we go for. So these are certain tips which will make your inorganic right at your fingertips. Can we move to the next one? Now, here the biggest and the hot chapters which we are having is bonding, then you know P block and coordination. And definitely after this complete class, you'll feel such a easy way you can score those 15 questions from inorganic. Let's move to the topic. Chemical bonding, right? We have there. So the biggest one, 2015 we are having, 16 we have three questions, 17, 18, 19. You can see that not less than four questions or three questions. So that means bonding should be apt in your mind. And such a easy topic, isn't it? Right? Bonding. So surely, definitely you'll get it because all shortcuts. Let's move to the hybridization, geometry, bond parameters, these are the way how you can go for the questions. Either they may ask from hybridization or geometry or bond parameters. Or the second way, they may be asking from molecular orbital theory, where bond order and stability definitely works. Next, hydrogen bond, dipole, resonance, ionic, covalent, or coordinate. These are the way how the framework of question is there. This year, if they ask you MOT, the next will be hybridization, right? You can just check the question papers. This is the way how the order comes. So these are the three ways how the question goes. Let's move to the topic. Hybridization, geometry, bond parameters. So hybridization, you know how to calculate the hybridization. We have the formula half VMCA, isn't it? We have this as the formula. This is the shortest way how we can remember. V is the valence electron of central atom. valence electron of central atom. Now, you don't have to remember the atomic number, children, because the group number will tell you what is the valence electron of the central atom. Group 1, you can take it as 1. Group 2, 2. Group 13, we have 3, 14, 4, 15, 5, 16, 6, 17, 7, 18, 8. That's it. You don't have to remember the atomic number. Next is monovalent. Here you have to remember, if hydrogen or halogen, then only go for this monovalent. So hydrogen or halogens, how many numbers are there? Just go for there. Then C stands for cation and A stands for anion. You just have to see, if on the top we have a negative, you add it. If on the top we have a positive, you can just minus it, right? So these are the ways how we can go for hybridization. The biggest part of the topic, because from here is what actually the topic moves, right? So we have hybridization, the values coming up. If we have hybridization answer, you are getting us 2, it will come as SP. 3, it will be SP2. 4, it will be SP3. 5, SP3D. 6, SP3D2. And 7 will be SP3D3. Isn't it? Right? So hybridization already you have learned. So this is the way, the shortest way which you can go for. The next is the geometry. We'll go for in the next slide what is the geometry, which you have to remember. Then bond parameters. We have bond angle, we have bond length, we have bond energy. All those will be coming up in the next slides, because the biggest chapter, 3 to 4 questions, we do want those shortcuts, isn't it? Right? And you are studied already in the form of shortcuts. Fine? Let's move to MOT, bond order and stability. No need to calculate. We have a direct way how you can get the answer. Hydrogen bond, dipole, resonance. So on to the next slide, because all this we are going to read it out. Let's move to chemical bonding. The factors influence the formation of ionic bond. These are the short things which you want. Big cation, definitely you can go for. Small anion, low charge on cation or anion. This is the factor which influence the formation of ionic bond. How ionic bond can be easily be formed. Stability. Is it stable? Once it is formed, is it stable? Depends on lattice energy. Lattice energy will tell you about the stability. Rules for stability is small size of cation or anion, high charge of cation or anion, right? So that was something which you can go for, the shortest way about ionic bond, how it is formed and what is the rule for its stability. Come to Fajan's rule. It's the tendency of covalency for ionic, because never a bond become 100% ionic or 100% covalent. So an ionic, how it will go for covalency. These are the points. Small cation, big anion, high charge on both cation or anion. Pseudo inert gas configuration. That means we have the D block elements and the S block element. D block will move more towards covalent, and the S block will be definitely ionic. Next, we have to find the stability of each atom in the compound. First, write the structure of the compound according to Lewis dot structure, and then go for calculating the formal charge. Valence electron minus number of electrons in lone pair. That short form if it is valence electron minus lone pair minus half into shared pair. Valence electron minus number of electrons in lone pair minus half into shared pair, right? So exceptions to octet rule, right? Again, can be a short question. These are the exceptions. Incomplete octet, group 1 to 13. Expanded hypervalent superoctet, any name can be there. Group 15, 16, 17. Odd electron concept, noble gas, hydrogen duplet, does not explain the shape, doesn't explain about structure, and all D block, definitely these are exceptions to octet rule, right? So these are the final way which you have to remember. Come to the next. Resonance, again a short question. Unsaturation leads to resonance. To find the resonating energy, we have the value resonating energy. We can find out by saying within the modulus actual energy minus energy of lowest energy part. This is what we have to go for within the, so even though if it is a minus sign it will come out as a positive part, no need to bother. Actual what is the energy that they will supply you minus energy of the lowest one, because the lowest is the most stable one. Come to the dipole. To find the percentage ionic character in a polar bond, do study that formula, right? Observed dipole by theoretical dipole into 100. Not going in detail, but go for the problem, because after so many years, they haven't touched that portion. So there's a small chance. Observed dipole by theoretical dipole. That dipole definitely depends on the charge. We have to find the stability, right? We have a lot of questions based on this, especially moving to organic. So you can just read out same number of unpaired electron, same number of contributing atom, opposite charges nearby, same charges should be far apart, otherwise they will go for repulsion. Correct assignment of charges, right? So the next one we can go for this, you have it in your book. This is what I told about geometry. So at the final stage you can just move to these portions, right? What is the hybridization? I have just put up, not to explain because you already know it. It's just to say this is the hybridization, this is the number of lone pair, and this will be the geometry, and this will be the shape. Geometry and shape. Don't don't forget this part. Geometry is the one which tells about hybridization, and shape will be when you go with the number of lone pair. Geometry എന്ന് പറയുന്നത് hybridization മാത്രം എടുക്കുക, and shape എന്ന് പറയുമ്പോൾ lone pairും കൂടെ എടുക്കുക, right? So moving to the next slide. This is our MOT theory, which we go for. Total electrons is 8, bond order is 0. Just go for that. 8, 10, all even numbers I have placed. So 8 total electrons, bond order is 0. 10 is the total electron, we have bond order as 1. 12 to move in this way because it's the most simplified manner rather than going for calculation in MOT, bond order. Because once you know the bond order, it's directly proportional to bond multiplicity, directly proportional to bond energy, directly proportional to stability, but inversely proportional to bond length. Now, let's move to the questions. So, which of the following pairs of ions are isoelectronic and isostructural? Count the total number of electrons. Count the total number of electrons. We have CO3 2 minus. Carbon, the total electron, that is 6. Oxygen, 8 3s are 24 plus 2, that is 26 plus 6, 32. Go for the next one. SO3 2 minus. Some of them have already might have done it and got the answer also. Sulfur, we have the atomic number of sulfur are 16. 8 3s are 24 plus 2, 26 plus 16. That will be 42. It's better you go for trying all. ClO3 minus. Chlorine, atomic number 70. 8 3s are 24 plus 1. 25 plus 17. That will be 42. Right? So here only we got ClO3 minus SO3 2 minus. If we have a combination 42 42, yes, it's isoelectronic. Then to check isostructural also, one thing just to make it sure, you can move to all. Here maximum of them they don't have the same electron. ഇതിനകത്ത് എല്ലാത്തിനും same number of electrons ഇല്ല, ഇതിന് മാത്രമേ ഉള്ളൂ. So first check with Isoelectronic, right? That's the easiest way. അത് കഴിഞ്ഞിട്ട് മതി isostructural. മിക്കവാറും isoelectronic you will get the answer, isn't it? Right? Let's move to the next question. Which of the following represents the correct bond order? Here is where I told you that you can find the total number of electrons and go with the bond order. Now I have here O2 minus, O2 and O2 plus. Find the answer, then we will move to the option. Count the total number of electrons. 8 2s are 16 plus 1, 17 electron. 8 2s are 16 electron. 8 to the 16 minus 1, that is 15 electron. Now you can go for the answer, isn't it? Right? 14 we have bond order as 3. So 15 we will have bond order as 2.5. 16 we will have bond order as 2, that column. And 17 you will have the bond order as 1.5. 0.5 അങ്ങ് കുറച്ചു പോവുക. ഇനി നോക്കിക്കേ അവിടെ പറഞ്ഞത് കറക്റ്റ് ബോൺ ഓർഡർ, ഏറ്റവും കൂടുതൽ ബോൺ ഓർഡർ അവിടെ ഏതിനാ? O2 plus, O2 plus maximum. Then we have for O2 and then we have for O2 minus, right? So this is the way. Rather than going for each options, move in this way. Come to the next question. Hybridization. Hybridization of atomic orbital of nitrogen in NO2 plus. But calculate here hybridization is NO2 plus. Half of valence electron nitrogen. Nitrogen valence electron group 15. So it will be 5. Then oxygen monovalent alla, hydrogen or halogens only are monovalent, so we'll not go for oxygen. Above we have plus, so we will go for minus 1, so it will be 4 by 2, that is 2. We'll go for sp hybridization. Now we have two options nearby. Let's move to the next one also. NO3 minus, right? NH4 plus, you all know directly you can get half of nitrogen 5, oxygen വരുന്നില്ല, monovalent അല്ല, minus വരുമ്പോ we have plus 1 there, so it will be 6 by 2, that will be 3, goes for sp2. ശരിയല്ലേ? Right? Hybridization enjoy ചെയ്യാറില്ലേ ക്ലാസ് ടൈമിലും? NH4 plus half of 5 plus monovalent 4, then above plus, so we will be going for minus 8 by 2, that will go for 4, it is sp3 hybridization. So in line we have NO2 plus sp, then we have sp2, and the third one we will have sp3. So that's the third option. Either hybridization vannalum, we can move in this way. Then you all are very fast, you can do the calculation quickly, within a fraction you can get the answers also. So let's move to the next one. Which one of the following compound shows the presence of intramolecular hydrogen bond? When such a question comes, if you have the knowledge of the answer, please don't wait for the doing each and every options. Directly go for, like hydrogen peroxide. We know hydrogen peroxide, how we go for writing? This will definitely have intermolecular, because H is free there, O is free. The other molecule only will definitely help for. Only the other molecule. ഇവർ തമ്മിൽ, so intermolecular സംഭവിക്കുള്ളൂ. When we go for HCN, even here this H is free, so might be they can go for intermolecular, same or different. Cellulose, cellulose, remember from biomolecules we have biomolecules structures ഇഷ്ടല്ല, but then too ഇവിടെ വേണം. beta D glucose units, H OH OH H, then HOH beta ആയോണ്ട് OH H എഴുതിയത്, H and CH2H. Now full complete വേണ്ട, can just go for here only. Fine. So beta D glucose unit cellulose, we have a relation between one and the fourth one. ഇവിടെ ഇതേ മാതിരി ഒരു മോളിക്യൂൾ ഇവിടെ OH ആയിരിക്കും. അപ്പൊ H2O പോയി. Here that bond is not an intermolecular hydrogen bond, that is a glycosidic bond. പക്ഷേ ഇതിനാവാലോ അടുത്ത മോളിക്യൂളിന്റെ കൂടെ. This can go for the other molecule H. So definitely they will go for inter. Then between O and H there can be having a bonding. So that is intra. That means it has both the bonding, intra and inter, both they are having. Now concentrated acetic acid from organic, you know, it only has intermolecule HC. Right? It only has intermolecular. So what is our answer? That will be cellulose, right? Isn't it? Chemical bonding. Hopefully enjoying chemical bonding, isn't it? Fine. So consider the following species. Which one of these will have the highest bond order? Or 14 one the highest bond order. Any one which is we are getting as 14. Cn plus. Total electrons is what you have to pick up. Carbon 6, nitrogen 7 minus 1. Gone. 12. Leave it. 6 plus 7 plus 1. That is 14. ഇനി അടുത്തത് നോക്കേണ്ട ആവശ്യമുണ്ടോ? അടുത്ത ചെയ്തോ ചുമ്മാ just for practice. But we don't want it, isn't it? We got the answer. Then one thing is there for inorganic. What happens is we feel it so easy. That's why easily we'll try to tick mark it as fast as. Remember, if you go for a negative, you're losing your one question. So be readily, without any stress, strain, go for calculating and try to answer. Fine. Next one. Magnesium reacts with an element X to form a, see, such a simple question, to an ionic compound. Ground state electronic configuration of X, we are having 2s2, 2p3, the simplest formula. Magnesium, you know, the valency is 2. X, we have 2 plus 3, that is 5 valence electrons are there. So the valency for will be, valence electron is 5. Appa valency endai marum, valency will be 8 minus 5, that is 3. Any interchange ide, you get the answer, that will be Mg3x2, right? So get to the next question. Coming for our next question, we have, okay, among calcium hydride, beryllium hydride, barium hydride, the order of ionic character, remember that ionic character part, order of ionic character, hydride is stable, say there. So just to go for cation, big cation size, big cation size, another big cation size ara, barium, and then it will be calcium, and then it will be beryllium. Ionic ആ ചോദിച്ചേ, കോവലന്റ് ആയിരുന്നു നേരെ തിരിച്ചു മറിക്കാം, പക്ഷെ ionic ആ ചോദിച്ചേ. അപ്പൊ ionic ചോദിച്ചാൽ we have this order: barium, then we have calcium, then we have beryllium, right? One more thing, you know the answer. While picking up the answer, don't make a mistake. Let's move to the next chapter. What we are having, p block elements. ഭയങ്കര പേടിയാ p block. So many things to learn, right? But how it becomes easy is when you know what questions actually they have asked the previous year. Now let's see what questions they are asking. Then I have simplified your strain by putting all the reactions. Might not be I will be able to say all the reaction, but definitely I have placed on the slide. ഇത്രയും വർഷം വന്ന reactions എല്ലാ സ്ലൈഡിലുണ്ട്. That will help you. Reactions alle, strain, stress, forget it, because we have gone for all the reactions. The teachers are taking trouble for you. You just prepare by giving yourself a relaxation. So P block from group 13 to 18, we are going for oxyacids. Ida varunadu priority answer. Oxyacids structures. Reaction part, NCRT, only NCRT reaction part. oxidizing, reducing actions of various processes. These are the three things which they are continuously asking. So why we study unnecessary things, isn't it? Go only for those part. Oxyacids, structure, property, and hydrolysis. Sure, a question from oxyacid, structure, property, hydrolysis. Fine. So structure, once you know the structure, you are ready with all the aspects, right? So short thing for the structure. Phosphorus, we have, so it's a short part. I don't know how you have learned this also, you can try. For phosphorus, let's move to, you have oxyacids, hypo, phosphorus, ഈ പേരൊക്കെ പഠിച്ചു വരാനാ പാട്. Orthophosphorus, I'll give you a cut short method how you can remember. Orthophosphorus, pyrophosphorus. That's why I told you morning 1 hour, night 1 hour. That much is more than. Just go for the first word. Hope. Hope. That's what is we need during our NEET exam. Hope that should be the best day in your life. Okay, hope. Hypo, ortho, pyro. ഇനി തൊട്ടടുത്തത് എങ്ങനെ എഴുതാം? Again hope. We should never lose our hope. That's why many hopes are there. Hypophosphoric. Hypophosphoric. Rasne mati rick. എല്ലായിടത്തും orthophosphoric, go for orthophosphoric. Phosphoric. Pyrophosphorus, go for pyrophosphoric. Pyrophosphoric. അപ്പൊ ഇത്രയൊക്കെ ആയല്ലോ. രണ്ട് ഹോപ്പ്, phosphorus, 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 phosphoric. Right? Next, let's go for the formula. How to remember that? Start with, starting ഓർത്തിരിക്കുക, H3PO2. Ortho, H3PO3. H3PO. ഓരോരെണ്ണം ഇൻക്രീസ് ചെയ്യുക. H3PO2, H3PO2. Right? ഇനി ഒരു ചെറിയ ടേം. ഇത് H3PO3. This will be H3PO4. H3PO4. Pyro, we have, അപ്പൊ അത് കംപ്ലീറ്റ് ആയി. H3PO2, H3PO3 and H3PO4. Right? H3PO4. Here is what I have written. H3PO4. H3PO2, H3PO3, H3PO4. Pyrophosphorus. H4P2O5. ഇനി ഒന്നും ഓർക്കണ്ട, ഇൻക്രീസ് ചെയ്തോ. H4P2O6. Increase the oxygen. H4P2O7. Right? That's the way how you remember. Hope for the best. Hope. Hypophosphorus, orthophosphorus, pyrophosphorus. And the next side it will be Rick. H3PO2, H3PO3. And for ortho it will be H3PO4. O5, O6, O7, H4. Now how we can go for the structure? Even that is in a short way. P. Make 4 bonds. ഒരെണ്ണം കാണിക്കാം, റെസ്റ്റ് അല്ല അതേപോലെ. Right? Cover with hydrogen. Cover with hydrogen. One bond will be free. Don't leave it free. Oxygen. Fine. Now we have all the bonds satisfied. So let's see now what all remembers. P ചുറ്റും ഒരു 4 ബോണ്ട് വരയ്ക്കുക. Fine. H satisfy ചെയ്യാദ്യം. Then left free, go for oxygen. Now we have one more oxygen. Move it to O. Right? Complete H3PO2I. Oxygen, we have a double bond. Everyone is aware. Now that's our structure. So easily you can say it is a monobasic. Isn't it? Now here only, let's go for the second part. P. 4 bond വരയ്ക്കുക. H3PO3 അതോർക്കെ. PO3, H, H, H. Right? The bond is free. Right? O. Then we have O3 here. So 2, 3. Cover it with a double bond. That's it. So we have 2 OH group coming over there. And when we have ortho, let's complete with this part. H3PO4. PO4. H3PO4. Right? 3 bonds. Fill with hydrogen first. Then what is left? Go with oxygen. Next, we have 4 oxygen there. 1, 2, 3, 4. So how many OH we are having? 3 OH group we are having. Tri-basic, isn't it? So this is the way how you can remember rather than rote memorizing. Then we have H4P2O5. ഇതൊന്ന് ഓർത്ത് നോക്കാം. നമുക്ക് ഇതിനകത്ത് P2 എന്ന് പറയുമ്പോൾ PP ബോണ്ട് വരും. PP. അപ്പൊ എപ്പോഴാ ഈ POP ബോണ്ട് എന്ന് പറയുന്നത് വരുന്നത്? Might be questions asked in this way. If this is an odd number, surely it will be POP. If this is an even number, 6, surely it will be a PP bond. For even number with 2 P2, P twice is there. For odd number, this is the case. Even number, we have PP. For odd number, we have POP. The next is the rest. We can do it on your own. Same way we can go for P. Right? Here 4 bonds. Fill with hydrogen. One I can show you. Right? We don't have much time. So one I will show you. 1 hydrogen here. 1 hydrogen here. 1 hydrogen here. 1 hydrogen. I yellow. 4 hydrogen. Right? So we have 4 hydrogen. Let's complete with oxygen. 1, 2, 3, 4 equally കൊടുക്കുക. 6 partiality ഇല്ല. 5 ഇനിയും partiality ആയിപ്പോ. അതുകൊണ്ട് ആ 5 ഇടയ്ക്ക് കയറി ഇടുക. POP and fill with the right. When you go for 6, you have so easily when you go for 6, we have 4 bond, right? H, 3, 4, fine. 1, 2, 3, 4, 5, 6. And wherever oxygen is free, fill up with the double bond. And when you have H4P2O7, that oxygen should be in between. That's it. Fine. So this is the way how you can go for reaction and the oxidizing. I have put it in the slide. So this is about oxyacid structure, mainly coming from phosphorus. That's why I told you. Then sulfur also we were having such a short way. I'll just go for telling how you can remember. You can just write down sulfurous, sulfuric, sulfurous H2SO3, sulfuric H2SO4, right? Then next section, thiosulfurous, thiosulfuric, thiosulfurous H2S2O2, thiosulfuric H2S2O3, pyrosulfurous H2S2O4. Next, dithionic, right? First one was dithious, the next one dithionic H4S2O6, right? And then the same way, you just go for writing the structure. Write sulfur in between, go for that 4 bonds, fill with hydrogen, and then go for oxygen. The same way you will get it. So, sulfurous, sulfuric, 1 bundle, H2SO3, H2SO4. Then we had thiosulfurous, thiosulfuric, H2S2O2 and H2S2O3. Dithious, dithionic. We have H2S2O4 and H2S2O6. The same way you can go for write the structure and see, no need to memorize. Now let's go for the reaction part of it, children. The reaction part, important reactions from group 13 to 18. I'll go for all the important reactions only, but then to which one is more important, let's go for. The first one might not be, this can come for your basic concepts anyway, some stoichiometric problems. This one you know, it's about the borax V test. This is the preparation of diborane. Then preparation of diborane again. All this reaction somewhere in basic concepts will be helping you for the stoichiometric part. Okay. So each slide, just see all the, in 10 years, what all equations they have solved, all this is there in front of you. So no need to worry about reactions now. Diborane, very important. A very important reaction. Diborane on treatment with NH3, low temperature. If you feel so difficult, you just study it as B2H6.2NH3. That's okay. B2H6.2NH3. The options of it will come. That's what is why I have given in this way. It's same thing, B2H6.2NH3, B2H6.2NH3. That's the lower temperature. And by high temperature, we get this borazole, inorganic benzene and hydrogen. Was an important reaction. Next, all small type of reaction. Preparation of nitrogen, you have learned it. Heating, what we get, very pure nitrogen, acid, barium and nitrogen. Next one, again the important reaction. Doesn't feel so, but it's important. Calcium carbide and nitrogen gives nitrolim. It's used as a fertilizer also. Then, very important again these two reactions. How do you remember? If chlorine is excess, ഓർത്തിരിക്കുക chlorine excess എങ്കിൽ chlorine വരണം അപ്പൊ NCl3. If NH3 is excess, N vernam kuda. That's why nitrogen. This is what they ask. What is the gaseous part which is released? Chlorine excess, chlorine vernam kuda. NH3 excess, N vernam release on the. Which gases? So important one. Again the next important one. Dilute HNO3. What is the product form? Nitrous oxide. Important. Next. Again the important one. Zinc and dilute HNO3 but cold. That was hot, this is cold. Will give you ammonium nitrate. That is what you have to remember. Salt you can remember. Next, copper and dilute HNO3. So many times asked question. Nitrous NO, right? Nitrous oxide, NO. Copper plus concentrated HNO3. It is nitrogen dioxide. Again important. Sure questions, children. Sure questions, sure reactions. Come to the 16th one. Cane sugar on oxidation with nitric acid gives oxalic acid. Just remember in short way. A organic in between an inorganic one. Let's move to the next one. Again, some important ones coming with redox chapter. It might merge here with redox or direct with P block. You can have the 17th important. Fluorine with cold and dilute NH gives OF2. A question coming from there, sure question. Hot and concentrated, we have oxygen gas being liberated. NAF, this is what they ask more. OF2 and this will be oxygen. Important one. NaOH dilute will give out NaCl. You might have seen such questions in redox. NaCl and sodium hypochlorite. 20th with concentrated NaCl, NaClO3. Important ones. Very important slide. The next one. Again, an important reaction. You know from noble gas, it's a definite question. They can turn it over, combine with hybridization and ask you all, okay, if this is a product, what is the hybridization part? So 22 and 23, I will give damn important to it. Partial hydrolysis of XeF4 and complete hydrolysis gives XeO3. XeO3. Partial hydrolysis of XeF6 yields XeOF4 and XeO2F2. Complete hydrolysis yields XeO3. So what all I have marked, that is more important. The rest is also important. The last 10 years, all the reactions at one head, right? Let's move to the next one is questions we can go for. So, strong reducing behavior of H3PO2 is due to, definitely, you have to draw the structure. P. Draw that 4 bonds. Fill with hydrogen. 3 hydrogen. 3 hydrogen. Hydrogen H3PO2, right? Yes, children, when you solve the question, you should have that easiness or mentality in your mind. That smile should be there. Don't be sit like a stressed. You should have that small smile, right? I can Feel so that many of them, oh, inorganic reactions, have that smile on your face. Come to H3PO2. H3PO2, right? 4 bonds, H, filled with oxygen. Now go for how many oxygen? Double bond, right? That's the structure. Now, you know this pH bond will then decide about the reducing because it's not ionizable. This pH bond, it's not ionizable, whereas this can be. Fine. അപ്പോൾ ഏത് ഓപ്ഷൻ ആയിരിക്കും വരുന്നത്? Strong reducing of H3PO2 is due to presence of 1 OH, okay, and 2 pH. Very good, okay, very okay, isn't it? Restall is not telling about this. Reducing behavior എന്ന് പറയുന്നത് എത്ര pH ഉണ്ടെന്ന് നോക്കിയാൽ മതി. How many pH, right? If there is no pH, we will have a difficulty for reducing. അതായിരുന്നു ക്വസ്റ്റ്യന്റെ അർത്ഥം. Little bit from classification also. Formation of oxide ion O2 minus from oxygen atom requires, okay, that's what is the question, right? You might have understood. നമ്മളുടെ concept അവിടെ പറയുന്ന adding of 1 electron, okay, the reaction is good, where the delta H is negative. Adding up of 1 electron is good. But if the second electron comes, there will be electron repulsion. So the chemical reaction, they have to supply excess energy to overcome those repulsion. Hence the second reaction, we have the delta H as positive there because the energy is supplied there to overcome this. So which option we can go for? That's why I told you it's from electron gain enthalpy, a little bit classification, but since oxygen, it comes in P block also. Fine. To accept the second electron, this is what is the difficult. Though we know it's a noble gas, attaining noble gas, പക്ഷെ അതൊന്നും അല്ല ഒരു ഇലക്ട്രോണിന്റെ അടുത്ത് വേറെ ഇലക്ട്രോൺ, സ്പെഷ്യലി ഡ്യൂ ടു ഇറ്റ് സ്മോൾ സൈസ്, ഇറ്റ് ഗോസ് ഫോർ ദാറ്റ് ഇലക്ട്രോൺ ടു ഇലക്ട്രോൺ റിപ്പൽഷൻ. So you have know the wordings continuously what I was telling. Electron repulsion outweighs the stability gained by achieving the noble gas configuration. Move to the next slide. Many times repeated question again. The 10th statement. Which of the following statement given below is incorrect? Now this is somewhere you have in between certain reactions, right? So think and answer, but there will be definitely some easy grasping for them. Cl2O7 is an anhydride of perchloric acid. അറിയത്തില്ല, അവിടെ നിന്നേരെ നെക്സ്റ്റ് നോക്കാം. O3 molecule is bent, you know it. O3 molecule is bent, definitely. O3 molecule is bent, we know. So it is a correct statement. ONF is isoelectronic with NO2 minus. Even this you know how to calculate. Oxygen, 8 electrons, nitrogen 7, fluorine 9. That will make up to a total of 24. NO2 minus, nitrogen 7, 8 to just 16 plus 1, again 24. So that is also safe there, right? So our option still didn't come in correct. OF2 is an oxide of fluorine. No, Allah, OF2. So here now your real target is between 1 and 4 there. So here if we know that ഇങ്ങനത്തെ വരുമ്പോഴാണ് ചെറിയൊരു doubtful ഒക്കെ വരുന്നത്. Where you should know the entire chapter. OF2 is an oxide of fluorine. Instead, because അങ്ങനെ വരത്തില്ല oxide, it is a fluoride of oxygen. OL central. It's a fluoride of oxygen. Oh, central. Oxide of fluorine. So that's the incorrect statement. Now for the first one, let's see. Cl2OS is an anhydride. HClO4. In the book, you might have seen such a reaction, giving Cl2O7 and water molecule leaving out. Right? So it's a correct statement. This is the incorrect one. Fine? So moving to the next one. Here we have, so definitely right from the beginning, if you have a base, right, come to Darsana for that base part, right? We have the repeaters 2021 online live classroom plus video classes. Starts from July 1st, 2020. Exams, Neet, JEE, main, advanced scheme. Our targets are AIMS, JIPMER, IT, NIT, ISE, and ISO, right? So each and every part we can go for, right? Surely, children, these shortcuts you can't get from the textbook. So we want such a way of getting shortcuts. So come to Dasha, and definitely all these shortcuts with it studying for 10 to 12 hours will be decreased to 2 hours for one portion if we have such shortcuts, isn't it? In such a 2 hours lapse of time, we can say such a heavy topic of 10 such topics, then surely during such wide time, how much we can cover? Come to that 11th question. Among the following, which one is a wrong statement? PH5 and BiCl5 do not exist. We know about BiCl5. Bismuth inert pair effect. As we move down, the oxidation state decreases due to inert pair. So bismuth will have that +3 oxidation state. Hopefully I know that you all might be knowing oxidation state goes in this way. Group 15, the top one will be 5. താഴോട്ട് പോകുമ്പോൾ inert pair effect ആണ് രണ്ടെണ്ണം കുറച്ചില്ലേ 3. As we move down, this is oxidation for all. 6 comes to down 4. This is how you remember. So bismuth +3 is more stable. So BiCl5 does not exist. Right? So that is true. അപ്പോൾ PH5 കൂടെ ഓർക്കുക. ഈ ഫോസ്ഫറസും ഹൈഡ്രജൻ തമ്മിലെ ഇലക്ട്രോനെഗറ്റിവിറ്റി ഡിഫറൻസ് അത്രയും വലിയൊന്നും ഇല്ല. Then how can PH5 exist? So when we don't have that, so do not exist is the right. We want the wrong statement. Then p pi d pi bonds are present in SO2. Easily ഓർക്കുക. ഓക്സിജൻ അവിടെ 2p ആയിട്ട് അപ്പൊ p പൈ ബോണ്ടിങ് വരും. സൾഫറിന്റെ വരുമ്പോൾ it includes in 3s and goes to 3s വരുന്നു 3p വരുന്നു അപ്പൊ 3d empty എങ്കിലും ഉണ്ട്. So definitely we will go for that p pi d pi bonding. സമയം എടുക്കുവാന്നേ അത് അവിടെ ഇരിക്കട്ടെ, നമുക്ക് നെക്സ്റ്റ് നോക്കാന്നേ. SCF4 and CH4 have same shape. CH4 and the hybridization sp3 with no lone pair tetrahedral. Selenium tetrafluoride group 16 ആണ് selenium. So half of 6 plus 4 10 by 2 that will be 5. sp3d അവിടെ പോയി അല്ലേ, because lone pair ഉണ്ട് പക്ഷെ sp3d വന്നു കഴിഞ്ഞാൽ trigonal bipyramid അല്ല. So they will not have the same shape. ഒന്നിൽ അത് ഒരേ hybridization എങ്കിലും വരണ്ടായിരുന്നു, പക്ഷെ അതുപോലും ഇല്ല. So this will be, but you definitely solve it and go. Even though because we have a short time, that's why I'm saying this way, just go for sp3d. ഈ sp3dക്ക് ലോൺ പെയർ വന്നു കഴിഞ്ഞാൽ ഒരു ഷേപ്പ് പോലും ടെട്രാഹെഡ്രലുടെ പോലെ അല്ല. അതുകൊണ്ട് നമ്മൾ നോക്കുകയേ വേണ്ട, ആവശ്യമില്ല അല്ലേ. I3 plus has bent geometry. Do it. One option we have gone. Hybridization count ചെയ്യുക, ലോൺ പെയർ എടുക്കുക, and then find out will it have bent geometry or not. You know how to do it, isn't it? Fine. I3 plus നമ്മൾ ഒരു I3 മൈനസ് പഠിച്ചിട്ടുണ്ട്. Half of 7 plus 2 plus 1. So this will be minus 1. That will be 8 by 2. It is 4 goes for sp3 hybridization. Number of lone pairs in this. Iodine 7 minus bonded to minus 1 by 2. The lone pair edukkanane. 5 minus 1, 4 by 2. That is with 2 lone pairs. 2 lone pair വരുമ്പോൾ bend അല്ലേ geometry. Right? So already we got the answer there. Right? Move to the next one. Boric acid is an acid because its molecule. ഇവിടെയൊക്കെ അബദ്ധം പറ്റുന്നത്. Because contains replaceable H plus. Surely this is what is the structure we have. Formula. Surely it contains replaceable H plus. Gives up a proton a little bit less monobasic than 2. Yes. Accepts OH minus from water releasing proton. This is the answer, but how? Right? We have such a reaction where the teachers have given you very, very important, writing the Ka values and all. This OH from water moves to here and it comes as BOH4 minus. H plus is released in such a fashion. So releasing H plus is due to addition of water. But the more important there is OH is coming and joining over BOH3. അതല്ലേ important കൂടുതൽ. അപ്പൊ ഇത് തെറ്റല്ല. ഇത് തെറ്റല്ല. പക്ഷെ വരണേൽ this should be the actual format. Accepts OH minus from that HOH. Is it clear? So such type when questions come, please be careful. ആദ്യം തുടക്കം തന്നെ ഇട്ട് ടിക്ക് മാർക്ക് ചെയ്യല്ലേ, unnecessarily negative ആക്കല്ലേ. 13th one. In which pair of ion both the species contains SS bond? Now, here remember that trick what I told you. If with oxygen we have odd number, O will come in between. Right? That one concept, keep it in mind. S2O7. 7. So, O has to be there in between. I'm not writing all the structures, but O7, it's odd. So, O will definitely come in between. S2O3, there's a small discrepancy, we'll keep it over there. But 7, we are sure O will be there in between. 8, even number, we don't have O. SS tanne complete oxygen boy. S4O6, even number, we have their SS bond. S2O7, we have oxygen in between. So they have asked us where this SS bond is there. So SS, the strong bond will be there. Here we are having, that's not the answer because here we don't have. So we have, let's come to the answer. ഇവിടെയും പോയി. ഇവിടെയും പോയി. So we are taking up a chance there. ഇവിടെ O6, even ആണല്ലോ. Even ആകുമ്പോൾ we don't have to write it's there. So that means something with this thiosulfate ion. പേര് വേണ്ട, thiosulfate ion, S2O3. We have here an exceptional type of thio, right? Thio, we have this SS bond, right? For thio. Right? Thio എന്ന് പറയുന്നത് SS bond ഉള്ളതാ. Right? Then double bond ഇടണം എന്ന് ഒരു ആവശ്യവും അവിടെ ഇല്ല. ഡബിൾ ബോണ്ട് വരണം എന്ന് ഒരു ആവശ്യവും അവിടെ ഇല്ല. Right? This double bond, we can leave it out because, and you can give it negative. If you don't want to draw this bond, you can just give it a negative. Fine? So this is purely an exceptional case. So you'll remember it, S2O3, it has SS bond. And if that's the case, just go with even number and SS bond we are having. Come to the next question. കുറച്ചൊക്കെ ഓർത്തിരിക്കണം, inorganic, isn't it? See, mixed with environmental. Environmental is a merging also. Which oxides of nitrogen is not a common pollutant introduced in the atmosphere both due to natural and human activity? N2O, isn't it? You all require during your exam time. Okay, possibly not because it's a laughing gas, right? Where we forget our smile. The nervous system is numbing us with this nitrous oxide, but that is not actually laughing. So it's a pollutant. NO2, acid rain. HNO3 can be obtained. NO, nitrous oxide, incomplete combustion, definitely. But we don't have anywhere this N2O5, right, coming up because besides it's a solid there. So it will not create much of pollutant. The rest all is in the gaseous. You can remember in this way also, rest all are gaseous. So as rest all are gaseous, they will be a pollutant. Rest all are gaseous, that's why they will be a pollutant there. Let's move to the next one. The correct order of atomic radii in group 13 elements. We know this several times this question is being asked. Group 13 element, what is the atomic radii? So remember it nicely as we move down a group. As we move down a group, the size goes on increasing. But there may be some problem wherever the shielding effect comes. As we move down a group, size increases. But if shielding effect is there, there may be a small discrepancy there. That is where the point you have to remember. So let's move with, we know thallium. It should have that most size. Right? Boron, aluminium, gallium, indium, thallium. So the biggest size for thallium. Let's move with one option, then we will clear. Then it should be indium. And then probably what we feel so, it should come is gallium, because that's the next one. But here we have that shielding effect. Here is where we have that shielding effect. So remember that shielding effect. A shielding effect in right? Lot of gathering is there. So outermost electron will be pulled nearby, right? The third bench is completely filled with so many students. So the outermost students might be the teacher cannot approach over there. Or the other way also. Teacher might be seeing more the last bench students rather than seeing this 10 students. So such a case is coming over here. The outermost is pulled up to the maximum. So thallium, indium, aluminium, gallium and boron. Many times repeated question. ചെറിയൊരു change വരുന്നുണ്ട് തന്നെ. Please remember it. There are certain cases where you have to remember something, you have to remember, isn't it? Our brain should not be empty. Something should be remembered there over here. When copper is heated with, I told you, a sure question, with concentrated HNO3, it produces ഏതായിരിക്കാം concentrated, അതോർക്കുവേ ചാടിക്കയറി ഒരു ആൻസർ ചെയ്തത് concentrated HNO3. Dilute we have other, concentrated we have a different way, right? So concentrated HNO3 is there. You have copper nitrate and NO2, isn't it? ഇതേ സ്ഥലത്ത് അടുത്ത വർഷം ക്വസ്റ്റ്യൻ വരണമെങ്കിൽ zinc with a dilute, zinc with hot, zinc with, so you can decide. All these equations are important. പഠിച്ചു വെക്കുന്നതല്ലേ ഒരു question sure ആയിട്ട്, right? Take it for granted. This will be not this, but along with this, the other question might be a question for you. Fine. Hopefully, what all we say here, let at this moment it be the God's word sent to you. Fine. That is the only intention of teachers who are standing over on this platform. Whatever words they are saying, whatever they are saying important, let it be God's word coming to them that this should be the question, right? So when I prayed, what I say, please, this should be the question, right? And let my children have that whole 15 questions, 16, 17, 15 is that most inorganic, that 15 should be there with the whole correct, with no negative, right? Let's pray for it. But come to the 17th question. Which one of the following elements is unable to form MF63 minus ion? We know for going for the 6, you have to go for the D shell, at least the empty D shell. MF6, you have to go to the empty D shell. But the empty D shell, if it has to come, they have to reach at least the 3s or 3p state. 3s or 3p. ആ ലെവലിൽ വന്നാൽ മാത്രമേ ഡി എം ടി എങ്കിലും കിട്ടുള്ളൂ. അപ്പൊ അങ്ങനെ വരുവാന്നേ ഈ 3s3p പോലും അവൈലബിൾ, ഇതിന് എം ടി ഉണ്ട്. This has d shell electrons, this has d and an incomplete f and all. Fine. So in such a case d ഒട്ടും ഇല്ലാത്തത് ഏതാ? That's boron. Let's move to the next question. So that is going for the next chapter, right? Some questions I have written, right? We and you both can pray that this should be the type of questions. This should be the question. Let's move to coordination compounds. So we have VBT, CFT, isomerism, applications of coordination. You can see the graph moved to high peak that 2017. Fine. So a little bit where you have to memorize such a topic. So this year, your wish, we can make it whatever it is. Like, let's go to the question part of it. A little bit explanation there required, because these are some topics which we require crucially, right? Again, here there are certain shortcuts, right? So you enjoy shortcuts, that's why we are going for those shortcuts, right? VBT. VBT, we know there is coordination number 4 and coordination number 6 we are having. Coordination number 4, we have the hybridization as sp3 or it will be dsp2. Coordination number 6, we have sp3d2 or we have d2sp3. Right? And coordination number 4 and coordination number 6. Now, when this is being coming, where this will be coming? When you have a weak ligand, the outer orbital is what is filled up. Outer orbital. It's been also given one more name, that is hypoligated. And most often this you have to, but most often, don't take it as granted, most often it may be paramagnetic. Fine. So ഇതിന് 4 പേര് വെച്ച് പറയാം. Weak ligand will go for this. Outer orbital, since it is weak, outer will go for. Hypoligated, and it's paramagnetic, unpaired electron. Please do it and then confirm. Fine. Now, when you go for dsp2 and d2sp3, just the opposite of it. I'll just go for way of telling what it will be rather than writing weak ligand. Yes, you understood. It is strong ligand. Outer orbital, you say inner orbital. Hypoligated, hyperligated. Paramagnetic, diamagnetic. Don't study both. That was VBT. Appa CFT endina originate cheyide? Teacher, what is that weak ligand, strong ligand? How we will understand? So we want to know which is a strong ligand and weak ligand. So for that, CFT has given that concept. Right? Now, don't study all the ligands. Instead, you can go in this way. CO. Have all these are what ligands? Only 4 I am writing. All those 4 are strong ligands. Ethylene diamine and NH2 or NH3 we are having here. Fine. NH2 or NH3 we can have here. So these are the 4 strong ligands. Rest all are weak. Strong ligands. This one is CO, CN, EN, NH2 minus. Angane vanna this. Rest whatever is coming, come to sp3 and sp3. That CFT crystal field splitting theory. We have some more cases there saying us octahedral, tetrahedral, both we are having. I'll explain one because it's one and the same. Has a relation with pairing energy. Pairing energy is less. Pairing cheyan energy korava. Appa definitely ivar endu cheyum, pair cheyum. Pairing energy is less. And if pairing energy is less, that means they go for strong ligands. Because pairing energy is less. Pairing energy is less. Whereas for this one, it will be just the reverse. ഒരെണ്ണം പഠിച്ചാൽ മതി. Pairing energy ഭയങ്കര കൂടുതല, pair ചെയ്യില്ല. Pairing energy is too high, will not pair up. So this way you can remember. Right? So for weak field ligand, according to CFT, they say pairing energy is very high. And rest all you can with this. So pairing energy is more, weak ligand, outer orbital, hypoparamagnetic. Strong ligands, pairing energy is very less, and the rest all options the reverse of it. Appa eda strong, this is the strong. Pinne oru cheriya formula okke ille, delta tetrahedral ne ide madri the same way you can go for tetrahedral. Fine. So we have a small relation. I can't write the whole thing. That's why just remember this small relation for tetrahedral and octahedral. Right? So that was for CFT. Then isomerism when we go for, right? A little bit orally we'll go for geometrical structural. Structural so easy because we have ionization. എങ്ങനെ ionization കണ്ടുപിടിക്കും? Ligands, one part moves outside, second part moves inside. SO4 Br, Br agata SO4 portha, ionization, finish. Linkage, if we have ambidentate ligands like CN, NC, SCN, NCS, NO2, ONO, ambidentate ligands, we have that is linkage isomerism. Coordination isomerism. നോക്കണ്ട, രണ്ട് complexes ഉണ്ട്. The ligands are interchange. Two compounds. The ligands are interchange. That will go for coordination isomerism. The fourth one, solvate. Solvate, water should be there. ഈ water molecule എടുത്ത് പുറത്തിടുക, ഒരു molecule എടുത്ത് അകത്തിടുക. So interchange of water. Right? Rather than studying all the example, think in this way. Interchange of ions, ionization, ambidentate, that will be linkage. Right? Then Water is there, solvate, think about solvate, and if two complexes exchange the ligand, we have their coordination part. So that was about structural. Let's move to the optical part of it. Optical, we have two parts coming as geometrical and optical isomerism. Geometrical and optical. Let's see if the space available is there, then octahedral 6 we can go for a short part. Geometrical, we have coordination number 4 and coordination number 6. 4, sp3, sp3, sp3 will not go for, we have two parts coming under it. This is tetrahedral and dsp2, which is coming as square planar. Square planar. Geometrical will not be this, will not be coming for tetrahedral. Geometrical sp3 tetrahedral will not be coming. Just check for dsp2. So that becomes easy. Okay, geometrical coordination for sp3 tetrahedral is not there. Just check for dsp2, that is square planar. Let's move this optical part of it also. Optical is just the reverse. sp3 with the tetrahedral, they will have the optical isomerism. Optical isomerism is possible. The arrangement is there. For all dsp2s, it may not be there. Then for which dsp2 it is there? Bidentate unsymmetrical. Bidentate unsymmetrical. Right? For 4. For 6, let's see whether we can take it or not. sp3 tetrahedral geometrical is there, but only for square planar. For tetrahedral, it is not there. That is geometrical. Coordination number 4 തന്നെ optical നമുക്ക് പറയാം. Optical sp3 is there, but dsp2 is not there. Interchange ആവല്ലേ? dsp2 ന് bidentate unsymmetrical മാത്രമേ ഉള്ളൂ. Right? So that was for coordination 4. Let's move to coordination 6. Right? So hopefully we can go for a short part about it. Right? In very, very short way. I'll write it in short. This is surely a shortcut for you. Coordination number 6. How you can write? You can just practice it, because once you practice it, no need to write it and see. 1, 2, 3, 4, 5, 6. 6 signs are there. Then I will cancel this F. Right? Let it be here only. There I am cancelling it. It will be A to B, C, D, E. Count it and see. 2, 3, 4, 5, 6. Next, E cancel it. You can have M, A2, B2, then C, E I have cancelled. 2 to 4, 5, 6, 2, okay. So E I have cancelled it. I have made it to D, and then D I have cancelled it. I have made it to A2, B2, C2. A, B, C, D, E, F. Remove that F. One you can include in A. Remove that E. One you can include in the next molecule, that is B. Right? Then we can hopefully we have, so E I have removed and I have made it to B2. So okay, here is small, so that writing part should be proper. M, A2, B2, then we have C and D also, right? So just make it to 6, 2, 4, 5, 6. Then remove this D. M, A2, B2, C2. How the writing becomes so simplified, you can see. Fine. So these 4 sets. The next set you can go for is M. Now the next set you have to remember, this is coming as one set. M, A, B, C, D, E, F. Remove F. Make one here more. Remove E. Make B more. Remove D. Make one more there. Right? The next set start with A3. Just check, keep in mind that is total 6 should be there. A3, B, C, D. Next one. A3, B2, C. Next one, I will remove that C, make it to M, A3, B3. This is one set. That is one set. Now on the top, right? Let's go to the next set, Ma3B3. On the top, I'll go for the other set. I have started with A3BCD. Fine, I'll write it here a little bit. I'll write it here. I want all this together. So I'll write it here. A3B3 we have moved to. The next one will be Ma4BC. Right? Then on the top. ഇതിന്റെ മേളിലായിരുന്നേ അത്. Then we have A4B2. അതിന്റെ മേളിൽ വരുന്നത് Ma5B. ഒരെണ്ണം കുറച്ചു. And then we are having Ma6. ഇത്രയും ഒന്ന് എഴുതി പഠിച്ചേ. ബാക്കി ഞാൻ ഫോൺ നമ്പർ പറഞ്ഞുതരാം. Not my phone number, it's the phone number of this optical isomerism. Okay, so A, B, C, D, E, F, A to B, C, D, E, remove one and then go on increasing. These four should have been on the top, right? Then from the first, this is from the first we go for. So Ma6, this is the first one, the second one, third one, fourth one, 5, 6, 7, 8, 9, 10, and this is the 11th one. Now let's go for from the beginning that phone number. Let's go for from 1 to that 11. Right, from that 1 to 11, I'll write that isomerism. For geometrical, don't have to write and see. Remember this from 1 to 11, right? That will be 0, 0, 00, 222, 3, 4, 5, 6. The reverse of 6, that is 9. Then 9 plus 6, that is 15. That is the geometrical isomerism for it. You don't have to write and see. Fine. ഇവിടെ എഴുതിയേക്കാം 0, 0. Geometrical isomerism ആണ് 0, 0, 222. Right, 222. Then we have 3, 4, 5, 6. 6 നെ തിരിച്ചിട്ടു 9. 6 plus 9, 15. That's how you go for the geometrical isomerism without writing. If you remember this way or the way how we go for, right? So 15, we don't have any optical. Optical പറയാ, we don't have any optical. Here we have 4 optical. Here we have 2. Here we have to rest all 0. Where no optical illa. So easily we have gone for, isn't it? Right? Appa ivadanna thareyennu ange ezhuthi thodunguva. 5th vare, 4th, 3rd, 2nd, 1st ഞാൻ ഇവിടെ എഴുതിയിട്ടുണ്ട്. And then go for this phone number 00, 222, 3, 4, 5, 6, 9 and 15. Right? That's the geometrical isomerism. Optical isomerism ഒന്നുമില്ല 4, 2, 2 കഴിഞ്ഞു. Fine. So this is how you go for. ഇനി ഇതിനകത്ത് തന്നെ ഓർത്തിരിക്കാവുന്നത് Ma3B3. Right? A3B3. Somewhere we have came across. Yes, A3B3. അതിനൊരു കാര്യം ഓർത്തിരിക്കുക. Ma3B3 have a different typical type of geometrical isomerism. Right? Cis-ഉം trans-ഉം അല്ല. They go for facial or meridional type. Facial or meridional type of isomerism. With that much, let's move to the questions there. Okay, so for each question, might be you must have heard this short part before, not before, just now, but quote it in your mind, all this. Which of the following has the longest CO bond length? Right? Only one reason I will say. Which has the maximum negative charge that has the longest CO? Explanation പിന്നെ പറയാം. The longest CO bond length എന്ന് പറയുമ്പോൾ maximum negative charge. Which has the maximum negative charge. The maximum negative charge. Now, the reason I will put in this way. Longest CO bond means metal to carbon will be the least. Right? Metal to carbon will be the least. And that's why as the negative charge increases, this is the case what we have. So only one thing in mind, longest CO bond in the പറയുമ്പോൾ maximum negative charge. Right? Maximum negative charge. If we move in this way, it becomes so easy, isn't it, children? Move to that 19th question. Cobalt 3 chloride from several octahedral complexes with ammonia. Which of following will not give the test for chloride and with silver nitrate is a type of an important question where which says if you want to give the test for chloride, chloride should be present outside. If we want to have this test for chlorine, chlorine should be present outside. അപ്പോൾ total coordination 6 വരണം, കൊബാൾട്ടിന്റെ oxidation state 3 വരണം. So just check കൊബാൾട്ടിന്റെ oxidation state +3 വന്നോ, right? അതും check ചെയ്യുക. And chlorine പുറത്ത് വരികയും ചെയ്യണം. Let's write this part. It's cobalt C and small o, right? A small o ഒന്ന് huge ആയിട്ട് o എഴുതി പോയതാ കേട്ടോ, right? So when huge people are talking, huge thing comes, right? But it is actually small o. So COCl3.3NH3, we will write it as CONH3 thrice, right? We want that cobalt as oxidation state 3. Fine. Then ഈ 3 വന്നാലല്ലേ നമുക്ക് ഓക്സിഡേഷൻ സ്റ്റേറ്റ് അവിടെ 3 കിട്ടുള്ളൂ. X minus 3 is equal to 0. Full oxidation state 0. So X is equal to 3. So it combats with 3. But there is no chlorine outside. If chlorine is outside, then only it will give the test. Some come to the next one, then you will understand. CO NH3 4 ഉണ്ട്. അപ്പോൾ ടോട്ടൽ നമുക്ക് 6 കിട്ടാൻ കൊബാൾട്ടിന് +3 ഓക്സിഡേഷൻ സ്റ്റേറ്റ് കിട്ടാൻ total agathu 6 madi, 4 plus 2. 1 chlorine is outside, so it will take 1 chlorine. So hopefully here, now I don't have to write 5NH3, 1, so this will be CO NH3 5, 1 Cl, 5 plus 1 6, 2 Cl coming outside, 2 chlorine will be picked up. So here will be all CH3 there inside. CO NH3 6, right? All NH3 inside. So question maruvanelum 3 molecules will react, 1 molecule react, 2 molecules will be picked up, no molecules will be picked up. So that's the answer, right? Come to the next one. Again, I'll go for the short part of it. From the application part, it is application I didn't told you because organometallic compounds, sigma bonded, pi bonded. Sigma bonded nu parayumbo we will have S block elements, P block elements, metalloids, as well as we have zinc, cadmium and mercury. So iron carbonyl FeCO5, it is coming under endu nokkanam ee iron carbonyl okke ingane thannu kayumbo ee metal nokkiya madi. എത്ര ഉണ്ട് മെറ്റലിന്റെ അടി 1, so it will be mononuclear. മെറ്റൽ ചിലപ്പോൾ 2 ആയിരുന്നെങ്കിൽ വാട്ട് എവർ ദ കോംപ്ലക്സ് ഹിയർ 2 ആയിരുന്നേ ഡൈന്യൂക്ലിയർ, 3 ആയിരുന്നേ ട്രൈന്യൂക്ലിയർ, 4 ആയിരുന്നേ ടെട്രാന്യൂക്ലിയർ, that's it. So again see this 2 hour class, when we can say such a short form, remember what all we can say during the class section, how simplified the topic it will be. So again we have our aims batch, JIPMA, IIT, NIT, state CBSE syllabus, IIT NEET 2022 integrated +1 and +2 program, home support for this particular occasion with online classes till lockdown ends. Then we have the live classes, isn't it, right? So if you want such a easy way or methodology of studying, so please convey the message to all the others who are staying nearby. Come and join Krishna. Come to that 21st one. Without anything, we can say what's the answer for this without having much knowledge. The type of isomerism shown by the complex, isn't it? CO C small o, Cl2 En2, diethylenamine. Ionization will not be possible because there is no ion coming outside here. Coordination, we don't have 2 blocks there. Linkage isomerism, we don't have any of the ampidentate. So hopefully it will be geometrical isomerism, right? So we can write it cis and transform, right? Complete, I'm not writing just this is the transform, right? This is the transform. Cis you can take it anyway. Cl opposite verle. Fine. So move to the next one. The geometrical and magnetical behavior of the compound nickel tetracarbonyl R. Nickel tetracarbonyl complex, what it will come? Nickel, we know it's a 3D8 4s2 complex. The total oxidation state here is 0. 3D8 4s2. So I'll fill up that D shells, right? 1, 2, 3, 4, 5. Okay, don't fill first only, but I have gone for 1, 2, 3, 4, 5, 6, 7, 8. 4s2. Right? 4s2. Now just see that carbonyl complex there. CO, isn't it a strong ligand? Yes, it's a strong ligand. So it will try to pair up here. Right? Both will move there. So we have this S. Pinne 4 ullonda either sp3 or dsp2. DSP2. That's why we have to write and see also. Sometimes we say in this fashion, right? We have to write and see. ഇവിടെ വരുമ്പോഴത്തേക്ക് ഏതാ വരുന്നത് എസ്. അപ്പൊ പ്രോമിനന്റ് ആയിട്ട് പറയുന്നില്ല, right? Such questions. പിന്നെ നമ്മൾ ഒരു ജസ്റ്റ് ഒരു ഐഡിയ പറഞ്ഞതാ. CFT makes it very clear. Fine. Just a little bit. Yes, this can be the chance. Always for hybridization, para and dia, please write it and see that earlier tricks what I was telling you was it's just a part of it. Yes, how you can go about. So okay, so S is free there and P3 sp3, so hopefully it is tetrahedral and you know all those are paired, so it will be diamagnetical, right? So again I am saying hybridization and magnetic, please write and see. Okay, that clue was just to keep something in mind we can go for. Let's move to the next chapter, DNF block elements. Not much we can say about here because the questions coming, you all know which type of questions are coming, that's why, right? So 2015 we had maximum questions, then decline. Fine. Potassium permanganate preparation, just read it because might be for several years we didn't have from there, but redox properties, since redox is there, it becomes a bit important. Potassium dichromate trends, not all but certain trends do there, it is important. KMNO4, remember about the redox, which earlier classes you have got it then too, because that is the important part. In acidic condition, Mn plus 7 changes to Mn plus 2. In neutral condition, or when it is slightly alkaline, weakly alkaline, we have Mn plus 4, that's a change by 3. And when it is strongly alkaline, it is Mn plus 6. If these three concepts are there, redox and DNF, clear. KMNO4, 7 to 2, 7 to 4, 7 to 6. Dichromate, so easy. Plus 6 goes to chromium plus 3. Plus 3 to plus 6, plus 6 to plus 3. കഴിഞ്ഞു അത്രയേ ഉള്ളൂ. Iodine ചിലപ്പോൾ ചോദിക്കുമ്പോൾ, right, can go from 0 to -1 or -1 to 0. So these are the three places where you have to remember that redox problem, which is important. If potassium permanganate dichromate പറയുമ്പോൾ തന്നെ important thing is there. Then color and magnetic moment. Magnetic moment, we know that formula. Have question coming from this is equal to how much is the Bohr magneton, which says how many number of unpaired electrons are there. Color, definitely color, which says color electrons, number of unpaired electrons on the color undu, unpaired electrons ille color illa, right? So depends on number of unpaired. So ee rendu trend ettu koodal orthirikka, number of unpaired electrons is there, color will be there, can hope for DD transition, but if unpaired electrons is not there, we don't have. And this is the Bohr magneton part coming up over here. So these are the three things you have to focus more for your examination point of view. Move to the question number 23. Which one of the following ion exhibits DD transition and paramagnetism as well? Just now I told, if it has unpaired electrons, it will go for DD transition. Come to oxidation state. X minus 8 equal -1. So X equals 7. Mn plus 7. That means all the electrons are removed. Manganese have the ultimate oxidation state as 7. Chromium. 2x minus 14 is equal to minus 2. So x is equal to 6. Chromium's ultimate oxidation state is 6. Again, see, x minus 8 equal minus 2. X is equal to 6. Chromium's ultimate. So hopefully this is MnO4 2 minus x minus 8 equal minus 2. It will come 6. Manganese ഏറ്റവും കൂടുതൽ വരുന്നത് 7 അല്ലേ 6 എന്ന് പറയുമ്പോൾ it leaves 1 unpaired. So it will go for that DD transition. Come to our next question. The reason for greater range of oxidation state. കൂടുതൽ oxidation state വരുന്നേ. That means 7 വരാം, 6 വരാം, 5 വരാം, 4 വരാം, 3 വരാം. ഇനി ഓർത്തിരിക്കുക, higher oxidation state non-metal, acidic, covalency കൂടുതൽ കാണിക്കും. Higher oxidation, non-metal, covalency, and it will go for the covalent part of compound. Non-metal, acidic, covalency. Right? Lower oxidation state go for ionic. Okay. So reason for greater range of oxidation state എന്ന് പറയാൻ കാരണം അവരുടെ orbitals bonding ന് participate ചെയ്യും. The orbitals are participating in bonding. And if the orbitals have to be participating in bonding, their energies have to be comparable. So 5s, 6d and 7s, they should have comparable energy. Then only they will participate in bonding, isn't it? And that's why that's the answer. 25th. Name the gas that can readily decolorize acidified KMnO4. See the problem for redox coming up. Mn plus 7. In acidic condition, it will move to Mn plus 2. That is a change by 5. It goes for reduction. Reduction. So one has to go for oxidation. That means moving from lower oxidation state to higher. അപ്പോൾ ഇവിടെ ആകെ ചെയ്യേണ്ട ആരാ ലോവറിൽ നിന്ന് ഹയറിലോട്ട് പോകാം. കാർബൺ അതിന്റെ അൾട്ടിമേറ്റ് ഓക്സിഡേഷൻ സ്റ്റേറ്റ് ഇല്ല, ബുദ്ധിമുട്ടാ ഹയറിലോട്ട് പോകാൻ. നൈട്രജൻ അതിന്റെ അൾട്ടിമേറ്റ് ഓക്സിഡേഷൻ സ്റ്റേറ്റ്, സോ ബുദ്ധിമുട്ടാ അവിടെയും വരാൻ. ഫോസ്ഫറസ് 5 അതും ബുദ്ധിമുട്ടാ. സോ അവിടെ ആകെ ചാൻസ് ഉള്ളത് സൾഫർ ഡൈ ഓക്സൈഡിനല്ലേ. +4 നിന്ന് it will move to +6. So that's the answer. Move to the 26th one. Magnetic moment 2.84. Bohr magneton is given. Now some of them directly know the answer. You can mark it down, but that's not the way. Now how we can go for this is just count the total number of unpaired electrons. Remember nickel 3d8 4s2. Now how we will perform this? N equal to, we have the Bohr magneton 2.84. Take the square of both sides. You have n plus 2. I'll make it to nearby. It comes as 8. 8.94 calculated. So n plus 2 will be equal to 8. Simplify this. You will be having n equal -4 and n is equal to 2. So we'll stick to n equal to. Negative we can remove. 2 unpaired electrons. Appale manasilayi 2 unpaired ennu paranjappo thanne clear ayi. Edinatha varunathu 3d8. Isn't it? 3d8. 2 unpaired. So that should be the answer. Right? Ti3 plus. Avade scandium, titanium 3d1. Only 1 unpaired. Chromium 3. ബാക്കിയുള്ള കാൽക്കുലേറ്റ് ചെയ്യാമല്ലോ. ഫൈൻ. സോ അതേമാതിരി ഒന്ന് കാൽക്കുലേറ്റ് ചെയ്തു പോവാം. So moving to, hopefully you will calculate the number of unpaired electrons and see for each one what will be the Bohr magneton. Let it be a practice. ചിലപ്പോൾ question അകത്ത് chromiumത്തിന്റെ ഒക്കെ കയറി വന്നാലോ. So do practice it. Fine. I have told you, given a word, so chromium might be coming. Fine, might be coming. A chance. Come to classification of elements. Now here, what all things we have to go for? The real thing is this chapter, if you know properly, S, P, D, F, all will be clear for you. Fine. But if we study this whole fully. So from where all these questions can be asked? It will be radius, ionization potential, electron affinity, or it will be electronegativity. This is one set from where the question, either this or this or this or this. 2 questions coming, either from this 4, any one can be, right? 2015, 16, 17, 18, 19, 20, like this you can go for. Fine. Then acidic, basic, and electronic configuration. These are the 2 sections from where we can Go for expect the question. Now radius, please remember that down a group radius increases, across decreases. Isoelectronic, isoelectronic കുറച്ചുകൂടെ ഓർപ്പിക്കുക, isoelectronic. At that moment just study in this way. Negative കൂടൽ, size കൂടൽ, or greater nuclear charge. Greater nuclear charge. Remember in this way. Ionization potential. Remember for that second period, we have group 17 greater, then we have group 15, then we have 16. Fine. Then we have group 15, 16, അവിടെ interchange ചെയ്തു, right? 17 fluorine, 16 oxygen പുറകെ പോയി, nitrogen മേളിൽ കയറി വന്നു, right? Then we have group 14 there, then we have group 2 there, again Mari, and then we have group 13, and then we have group 1, right? ഇതാണ് ഓർത്തിരിക്കേണ്ടത്. ഇവിടെ ഒരു ചെറിയ മാറ്റം, that is beryllium boron interchange, right? Beryllium and boron, please interchange it. And we have nitrogen and oxygen, please interchange. ബാക്കി എല്ലാ ആ ഓർഡറിൽ അങ്ങ് നിന്നോട്ടെ. Electron affinity, again electron affinity, we know it should be negative. അവിടെ ഓർഡർ മാറുന്നത് നമ്മുടെ, so ഇവിടെ വരുമ്പോൾ fluorine, then you have from group 15 nitrogen, and then oxygen, then we have carbon, then we have beryllium, boron moving down, and then we have lithium. So remember this part, because again we have electron affinity also coming up in this way. Electron affinity, you have negative values, remember, but fluorine and chlorine, due to electron repulsion, fluorine moves down, chlorine moves ahead. ഇതൊന്ന് ഓർത്തോണേ. ക്ലോറിന് കൂടുതൽ വരും, പിന്നെ ഫ്ലോറിൻ, and then as usual bromine, iodine. അതേമാതിരി ഓക്സിജൻ, സൾഫർ, സെലേനിയം, ടെലൂറിയം, പൊളോണിയം ഒക്കെ വരുമ്പോഴത്തേക്ക് the real fact is oxygen goes at the least bottom, പൊളോണിയം കഴിഞ്ഞ്. So electron affinity, sulfur, then selenium, then tellurium, then polonium, and then it is oxygen. So that part can be a little bit. Electronegativity, just okay, the definition. Acidic, as we move from left to right, acidic increases, basic decreases. Electronic configuration, hopefully from D block elements, we can go for that part. So let's move to that question section. 27th. The element Z equal 114 has been discovered. 114. 14, group 14, that means the outermost should have 4 electrons. And where the outermost? Here the outermost 7, outermost 4, outermost 6, outermost 8. So hopefully it is the second one. Come to the next section. Next question. So, in which of the following options the order of arrangement does not agree with variation of property indicated against this? Hopefully you have understood which is the wrong order. Order of arrangement does not agree, wrong order. Isn't it right? After nitrogen, oxygen, then carbon, then boron, carbonyl. Then, increasing electron gain enthalpy. Fluorine ആണോ കൂടുതൽ? ഇത് interchange ചെയ്ത് വരണ്ടേ? Right? Fluorine ഇങ്ങോട്ട് ചാടി, chlorine ഇങ്ങോട്ട് ചാടി, അല്ലേ? Fine. Babaki increasing metallic, and we have increasing ionic size is the correct one. Move to the next one. See, that's why I told important. Which of the following represents the correct order of increasing electron gain enthalpy with a negative sign? Whatever it is, that means more electron gain enthalpy. Kodal edina varunathu? Group 17 ആദ്യം, chlorine, then fluorine. Group 16, sulfur, and then it is oxygen. So that order was what I told you, it is important, right? It is important. The 30th one. Such a type of question you can expect, and good also. The first ionization potential in electron hole of beryllium and boron. We know beryllium should be more than boron, because the reason I told you, right? So that depends upon half filled and completely filled. Beryllium koodal varanam, boron korra varanam. Appo ee rendu option endayalum varilla. Beryllium koodal varane, it should be the fourth option. So again we have, see, for long-term batches, +1 science tuition, Neet, JEE, KEAM, entrance for 10th completed students. That's very important, children, because right from the base, if we know about periodic table, hopefully chemistry will be so easy for us, right? So, among the following, which one is the most basic one? Basic. That will be from group 1. Group 1 illa. From group 2. Group 2 ഉണ്ട്. That's it. Coming to S block, we have comparative studies of alkali. Here is somewhere it's being spreaded like this. So just study the trends, hydration enthalpy. Then we have reducing characteristic of both alkali and alkali. This is the place where a small difference is there. Hydration, lattice, reducing character. Reaction of metal with ammonia. Long far the question is not been asked. So just go for that. Metal plus ammonia, blue solution, paramagnetic turns to brown, etc. etc. You can go for that portion right now. So coming to the whole set of reactions, important reactions, right? Sodium monoxide, peroxide, superoxide, lithium nitrate. Do follow this because sodium nitrate, all these are important, right? All these are important. Ask 2 to 3 times. Come to the 32 part. Which of the following oxide is most acidic? Most acidic. Immediately don't jump and go for most acidic should be the smaller size cation because anion is constant. Small cation. Small cation, smallest cation. Which is the smallest cation there? It is beryllium oxide. 33rd. കുറച്ച് കാമായിട്ട് ചിന്തിച്ചു വെക്കണ്ടേ. Which one of the following has minimum value of size of cation to anion? So cation by anion. If you want minimum, cation should be less size and anion should be big size. Anion should be big size. So let me write that small periodic table for you. Sodium, potassium, then magnesium, calcium. From these two, this is the biggest size. Among K and calcium, this is having biggest size. Among sodium and magnesium, sodium have the biggest size. And as we move from left to right, definitely the size goes on increasing. Now from Na and K, Na is having the smallest. That is the biggest. Ini idu ittere. Magnesium, calcium. Which is having the smallest size? The smallest size is for magnesium. So hopefully magnesium will have the less size, isn't it? So this should be for magnesium. And see, fluorine, I told big size, but fluorine is having small size. So hopefully that will be MgCl2. 34. In reference to biology, to biological role, calcium ions are important in triggering the contraction of muscles, right? So more than me, better you all know biology push. Ionic mobility of which of the following alkali metal ion is lowest when aqueous solution of their salts are put? Lowest. That means moving is less. When ionic mobility, movement is less. Because അവർ വെള്ളം കുടിച്ച് അങ്ങോട്ട് ചേർക്കുക കേട്ടോ. വെള്ളം കുടിച്ച് ചേർക്കുക. വെള്ളം കുടിച്ച് ചേർക്കുന്നത് ആർക്കാ? സ്മോളസ്റ്റ് സൈസ് അവരെ ഏറ്റവും കൂടുതൽ വെള്ളം കുടിച്ച് ചേർക്കുന്നത് അല്ലേ? So lithium drinks lot of water, right? Just saying, it intakes lot of water. So hydration is maximum, and since it has got lot of water, it becomes bulky. Now it can't move, so ionic mobility is less. So that was for lithium. Okay, that was for lithium. 36th. The product obtained as a result of reaction of nitrogen with calcium carbide, right? So can be a chance there in asking in environmental because it is acting as a fertilizer there. Once a question was having a small mistake also, calcium carbide on reaction with nitrogen forms CaCN2 plus carbon. This reaction mixture is called nitrolim, which is used as a fertilizer. 37th question. Solubility of alkaline earth metal sulfate. Now here I want to say something about stability also. Stability, a small part, because stability we can, for group 1, group 2, you can use this concept. The concept says that big cation, big anion, stable, or small cation, small anion. This is stability. This is stability. About stability. Big together good, small together good. That is stable. That's the rule for stability. But if we have big and small or small and big, the stability loses. So big, small. That's the ideology for stability, right? Big, or you can't have both together. Big, one option big, other is small. This way it will not come. So either big cation, big anion will be there, or you will have small cation, small anion, and that's the ultimate stability is rule. For big കൂടുതൽ ചേരുള്ളൂ, small ചേരുള്ളൂ, right? That was stability. Solubility, for group 1 a little bit, because solubility deals with hydration and lattice. We have to remember it because both the concepts are opposite, right? So solubility for group 1, for carbonate, bicarbonate, leaving the halogens and hydride, leave halogen and hydride വിട്ടിട്ട് ബാക്കിയെല്ലാം സ്റ്റെബിലിറ്റിയുടെ അതേ ഓർഡർ ഒക്കെയാ പോകുന്നത്. പക്ഷെ ഓർഡർ സ്റ്റെബിലിറ്റി ആണെന്നല്ല റീസൺ എന്ന് പറയുന്നത്. റീസൺ ഈസ് യു ഹാവ് ടു ഗെസ് hydration or it will be lattice. Both have different concepts. So ആൻസർ കിട്ടാൻ സ്റ്റെബിലിറ്റി എന്ത് പോയി, അത് തന്നെ solubility എടുത്തു. Leaving hydrides and halides you have to learn. Now for solubility of alkaline earth metal, as we move down, hydroxide solubility increases. But for sulfates, as we move up, the solubility increases. For sulfates, your teacher might have given you a short form for that, right? For all hydroxide, as we move down, solubility increases. For sulfates or the rest all, sulfates, nitrates, etc., as we move down, solubility decreases. So magnesium has the most. Next, which of the following element is extracted commercially by the electrolysis of an aqueous solution of its own compound? We know aqueous solution of its own compound, we can go for sodium. So again, see all these points which is related to in the short form will be possible or will be successful. Your dream of becoming a doctor or an IITian is possible when you join Darsana. And that's directly right from your foundation, long term, definitely it will be helpful for you a lot. So our plus 2 science tuition, Neet, JEE, KEAM entrance for plus 1 completed and plus 2 school going students is there for you, always helping and serving you. Till now we are serving you all, right? So lockdown or whatever is the situation, doesn't matter. Darshana is always at the doorstep to help you all, right, till the last moment. So hydrogen, hardness, hydrogen and hydrogen peroxide question. Then water, a small question coming from there. So hardness can be a type of question. Hydrogen, see the graph, a little bit questions only coming from this topic. Moving to hardness, remember that temporary and permanent hardness which we were having. Temporary hardness and permanent hardness. Remember the ions based on it. Cations we are having, yes, cations we are having calcium and magnesium ions. Calcium and magnesium ions. For anions, we are having bicarbonate, and here we are having chloride and sulfate. So if we are being asked, you can sulfate SO4 2 minus. So you can easily guess which is the temporary one. Calcium bicarbonate, magnesium bicarbonate, calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. That is hardness. And how to remove hardness? For temporary, we are having boiling Clark's method. Remember, for boiling Clark's method, use calcium hydroxide. Then permanent hardness, we have the methods like Calgon's process, sodium tetra, right? phosphate, Na2, Na4, PO3, 6. So remember about that formula and some questions relating to the concepts, right? Questions I'm not saying, but definitely go for that part. Just read it. Then we have resins, saying organic part, removing the cationic part and the anionic part, resins, that is important. Then we have washing soda, which can be included for both, for temporary as well as permanent. So that is what you have to. Hydrogen and hydrogen peroxide preparation, please just overlook. And hydrogen peroxide, we have a short part saying about structure. Actually, hydrogen peroxide, more than hydrogen, we can just stick to that hydrogen peroxide. That short portion is very, very important. So if it is your last minute revision, do go for hydrogen peroxides, that entire topic. Then water, we don't have as much questions coming from there. Coming to the structure of H2O2 is, structure of H2O2, it is, right, open book, like computer open ചെയ്ത് വെക്കുന്ന പോലെ, the dihedral angle between it. So it is non-planar, right? So you can expect such a question also. OO, the bond length, OH, the bond length, right? Which is more, see, by drawing only we can know OA, little bit more distances there, electron electron repulsion, a little bit more if they have to ask from the question. Remember the points which I have told you. When you go for the last 10 years questions, follow it thoroughly. That means from each question, what all points you can get from, so that the next year from the same question, another question can be originated. Just now I told the structure is non-planar. From that structure, they can ask you several questions like calculate the hybridization, follow the same hybridization rule, half VMCA. They can ask you OO bond length, OH bond length, etc. So related things can be asked. That's why the whole concept, അതാ ഉദ്ദേശിച്ച concept thorough ആയിരിക്കണം. ഒരു ക്വസ്റ്റ്യൻ വരുന്നതിനകത്ത് പല ലിങ്ക്ഡ് ക്വസ്റ്റ്യൻസ് കാണും, ആ ഓരോരോ ഓപ്ഷൻസ് അത് നോക്കുക. That is, follow that 10 years previous question. Inorganic full marks is there, right? Don't worry about it. And most easily, ഈ 15 questions solve ചെയ്യാൻ, I'll tell you, physical and organic, where it takes lot of time, inorganic, those 15 questions, hopefully 16, 17 questions, it will just take you 7 seconds or 8 seconds. Read it and you can answer. So, ഏറ്റവും കൂടുതൽ പ്രോഫിറ്റബിൾ ആയിട്ട് വരാം. ബിസൈഡ്സ്, your mind is on the right track, no stress, no tension, and you can take the topic, right? So coming to the temporary hardness of water, it is due to the presence of calcium bicarbonate. Next one. Which of the following statements about hydrogen is incorrect? This is, hydrogen never acts as a cation in ionic salt. Isn't it right? For ionic hydrogen, how it can go for acting as a cation? Hydronium ion exists freely in the solution because H plus will combine with that oxygen's lone pair. H plus will combine with that oxygen's lone pair and it will form hydronium ion. Earlier H plus is more there in solution, but after sometimes hydronium is more there. Dihydrogen does not act as a reducing agent. Where we have studied the properties of hydrogen, there we have reflected hydrogen can act as a reducing agent more than an oxidizing agent. So obviously this is the statement where a small disturbance is there. Hydrogen has 3 isotopes, of which prosium is the most common one which we are having, isn't it? Right? Once a question, 2016 or 17, but a small problem with the question because third and fourth option, but we have changed the question there. So coming to metallurgy, you know what question is definitely asked. Study all the O's. That should be the last minute preparation. Study all the O's, children. Then reduction and refining, Ellingham and extraction is just after this. Ores, that's the targeted topic from metallurgy. There where you have to memorize a little. And For metallurgy part, definitely the whole extraction you can just remember in this way, in a short way: ores, powdered ore, concentrated ore, crude ore, and we have pure metal. Your last minute preparation should be all those which are coming in between this. All those which are coming in between this. That is the whole topic what you have. Study all those. A pure question from this. Maximum important. Reduction and refining. You have tabulated columns say which one goes better with which one's reduction. Ellingham concept. Probably. Because 2018 we had a question, so a chances there for 2020. And extraction, iron, zinc, copper, then silver, gold. Just study the reaction part of the extraction part. Reaction portion, please study from the extraction. That's more important. Only the reaction part. Let's move to the question part of it. So we have 42. Extraction of gold and silver involves leaching with cyanide ion. Silver is later recovered by. We have to know that whole reaction. Then we can go. Silver ore on treatment with sodium cyanide or potassium cyanide forms the complex sodium argentocyanide. Ag plus 1, Na plus 1. So Cl we have to take probability 2. Now, this is the soluble complex. If we have to remove silver outside, we have to go for hydrometallurgy, reduction by precipitate. Zinc displaces silver, silver moves outside. You have Na2, Zn, Cn4, sodium tetracyanozincate 2 ion, right? That can be asked for your coordinations IUPAC. Sodium tetracyanozincate 2 ion. So hopefully that is displacement with zinc. See how we have connected the coordination with metallurgy. Which one of the following is a mineral of iron? That's probably it's from the ore part. It should be magnetite. That is Fe3O4. Cassiterite, it is SnO2. Malachite, it is copper carbonate, copper hydroxide. Pyrolusite, it is MnO2. Move to the 44th question. Consider the Ellingham diagram. Which of following metals can be used to reduce alumina? Don't know how many of them knows this short form, but we go for PSC, muscle, hydrogen, copper, message. Isn't it? Hydrogen, copper, message. The one which lies on the top, they can displace all. Right? So alumina, if I have to reduce aluminium, hopefully it can be done by magnesium. All the one which is on the top, they can reduce or displace the one which is present at the bottom. Right? Environmental chemistry, just say you which topic you get. Ozone gases. So many times a repeated question. Right? Ozone gases. Now, how to remember? How I used to remember, I'll say. CCC, CH4, CFC, carbon dioxide. Then water, nitrous oxide, water vapor, nitrous oxide, and ozone. Right? CCC, CH4, CFC, CO2, water, nitrous oxide, and ozone. This is how I remember about ozone. Then the next thought is photochemical smog, right? London smog, classical smog, photochemical smog, right? So remember the difference between those two. Fine? The classical smog as well as the photochemical reducing, oxidizing, SO2, okay, all those are theory. Then do remember about it again from, so hopefully from water pollution, BOD, COD, just read that portion. BOD, COD. BOD for 5 days, 1 liter water, 20 degrees Celsius temperature. We go for if the sample BOD content is below 5 pure water, 17 a little bit impure, and above 17 it is a municipal sewage. Fine. So those topics. So environmental, the last time reading you can go for which all topics I would say. That is, you know about primary, secondary pollutant. Primary starting, secondary when combined with together. So read the ozone gas. Last time also it came. Then read about all those water pollutants in the text, that ppb, ppm, we don't remember this, that's why. So from there you can be asked a question. Then we have photochemical smog, as well as we have classical smog. From there a question we can expect, or otherwise a combined question. Now let's go to that question number 45. Which one of the following statement regarding photochemical smog is not correct? Now whether it is photochemical or whether it is we have the other part, for both it will be an incorrect statement, because photochemical smog does not cause irritation in eyes and throat, will never happen, it is a pollutant, so it will develop an irritation. Carbon monoxide does not play any role in photochemical, it's the beginner initiator. Photochemical smog is an oxidizing agent in character. The other one was reducing. Classical is reducing. Photochemical smog is formed through photochemical involving solar energy. Each and every requires solar energy, but does not cause. For classical or photochemical, both will be playing the same role. Come to the 46th one. Which of the following is a sink for carbon monoxide? Yes, it was around 2006, 2016, 2017 was a crushing question for most of the students. So remember about all those. Which of the following is a sink? Capturing carbon monoxide, microorganism present in the soil, right? Ocean will act as a sink for sulfur dioxide, carbon dioxide. NH3, it will act as a sink for NO and NO2. 4 days it will remain, and this one will be 3 days, right? So remember, hopefully might be repeated to 2020, can be a question. Green chemistry, again, a lapse of time, green chemistry is not been asked, so we can definitely go for expect. So zinc, probably according to me, zinc can be a question. Green chemistry, hopefully, because ozone is repeatedly coming, so then this can be. Green chemistry means such reactions which produce color change, no. Reduce the use and production of hazardous chemicals. That's the definition of green chemistry. Depletion, study the reaction, so making the whole surface green, nothing but when we prepare certain substance, use less amount of hazardous. That's what is the basic concept for green chemistry. Next, we have chemistry in everyday life. Such small topics when it comes, how we can revise all those is difficult. So your teachers might have supplemented with you all the drugs under one section, like analgesic, all the drugs, antipyretic, all, antiviral, all together, antiseptic, all together. So before 2 hours of pronouncing of the exam, just read out all the list. Just read out all the list because it's difficult to buy. So that one portion. Hopefully question from there. Next, we have from food preservatives. For that, we have sugar part, allicin, aspartame, allicin the maximum, aspartame. Then we have allicin 2000, sucralose 600, saccharin 550, and aspartame that is around 100 types. So that section can be for several times. From here we haven't got a question. Then we have antioxidants, BHT, BHA, butylated hydroxytoluene, butylated hydroxy anisole. And we have detergents, cationic, anionic, non-ionic type of detergents, right? Now, as far as teacher says this is important, that is important. So let's stick to one part. From a lapse of time, they haven't gone for a question coming from bactericidal, bacteriostatic. So just to make a view on that, bactericidal, bacteriostatic. Then a question from subversion, right? That is from the textbook, cell version. So hopefully we can expect a question from over there, right? Then cationic, detergent, anionic. That's my choice. Let's see what happens in 2020. Isn't it chemistry in everyday life? Let's have the question part from here. So I expect the questions around from here. That is might be from cationic detergent, anionic, to identify which one it is, or it will be from bactericidal, bacteriostatic, that type. We can go for, so stick more to this part, and then definitely salvation is more, because they also have targeted the topic in this way. They have given the structure and asked it belongs to which, right? So don't go much for structure, unnecessarily wasting the time. So these are the three what I have targeted for. Let's go to mixture of chloroxylenol and terpinol. It acts as it is a combination of, yes, at present it's very much essential when we move from outside, when we go back to home. This is a very essential thing. Wash your hands with Dettol, and that is definitely a very good antiseptic. Let's hope so that all these things comes to an end, isn't it? Dettol, much we don't have to use it. Such an occasion, let it come. Which of the following is analgesic? Analgesic. See, all these three coming under one. Bacteria, antibacterial side. Only Novalgin. Novalgin. This is a market branded name also for analgesic. Also acts as an antipyretic. Analgesic as well as antipyretic. Antipyretic reduces the temperature. Analgesic, it's a painkiller. Okay. So Biethanol, generally added to soap as an additive. Again, at present, we want in our each and every soap product, we want this biethanol at present occasion. So you understood at present occasion why this biethanol is needed. It will act as a antiseptic, isn't it? Right? So hopefully from here, what all questions I have told you, please prepare all those, right? So that was from inorganic, children. That 5 points. Stick to your NCRT. Then following the order, priority, study morning and night. Just spend 2 hours. Right from today, inorganic is at your hand, and go on seeing the slides repeatedly, because the 10 years repeated all the reactions I have placed on the slide, because maximum students are feeling uncomfortable with the reactions. So that 30 reactions, it's all from that 10 previous years question. And all those questions which I have highlighted here, that is 10 years previous questions, but whatever I have highlighted, it's an intention from my side. Hopefully these concepts will be coming. So hopefully, I think so, right? A little bit speedy, but then too you have understood. Stick to the questions, stick to the reactions, stick to the concepts what I told. Give 1 hour morning and 1 hour at night time for inorganic. So in your dreams also let inorganic hang over for the next coming 10 days. And from the whole Darshana team, we bless you all, right? And a very, very good luck for your coming exams, right? Hopefully all of them move with flying colors out, right? Should have that smile on your face while entering, and a big smile when you come back, right? That's what is our intention. We all are praying for you, my family members, the people around our area, all are praying for you. So thanks a lot. Thank you for listening patiently.